Hi. You guys excited at all? Very cool. Today we're going to be talking about Kubernetes and best practices for orchestrating the cloud with it. We'll have some live demos of using industry standard tools like Docker and Kubernetes. You'll see us break down an app into maybe microservices, package that up in a container, distribute it, and then we use Kubernetes to manage that. I'm Carter Morgan, developer programs engineer at Google. And I was going to give this talk with someone else. He couldn't make it, so I'll be driving all the live demos and whatnot. Now, before we get into it, I want to tell you my story. When I started at Google 6 months ago, I had never worked on the cloud before. I had programmed emulators and compilers at Microsoft. I'd done threat databases at the Air Force, but I'd never worked at the cloud. So when I started trying to ramp up, it was overwhelming. There were so many tools, so many different processes. I didn't know where to begin, where to start. Luckily, one day I ended up on a bus next to this guy that was literally writing the book on Kubernetes. I told him my problem. I said, I'm having a lot of trouble ramping up. And he gave me 2 words of advice. He said, use Kubernetes. And I said, you want me to learn another tool on top of everything else I'm juggling? And he said, yeah. And so he showed me Kubernetes over the next 2-hour bus ride, and it turned out he was right. Kubernetes offered abstractions that made sense. It made the cloud more approachable. Instead of focusing on the machines, I was able to focus on what I knew, my application. And so we decided to make a course. Over the next 4 months, I got to work with and learn best practices for approaching the 3 major hurdles to writing scalable applications online. And so by the end of this talk, you have seen this in practice with live demos. So the first hurdle is the application itself. I'm not sure why the image is split. Oh, it's not. OK. So you'll see on screen, I have a picture of a monolithic application and a microservices. We're going to be demoing these today. And they're functionally equivalent. They do the exact same thing. We just took a different design approach. So how this app works is you can hit an endpoint and get back a hello response. It's a very, very polite application. If we hit a secure endpoint, we're not going to be able to get access unless we have the right token. Both of these do the same thing, but there are pros and cons to the different approaches we took. With microservices, some of the benefits are that we can have independent deployment. So my auth service or my hello service can be compiled and shipped out separately without recompiling anything else. They don't touch. I can use different languages for that. So I could use Go for hello and auth, and I could use Node.js for the front end if I wanted. And then also, these services are smaller, which means that they're easier to maintain and manage. One person or a small team can own any of these services from end to end, from building the code to running it in production. Now, these advances in how we design applications were made possible by advances in application isolation technologies like containers and VMs. What containers and VMs were developed to solve were the problem of, it works on my machine. We wanted something that was reproducible and reliable and that would work on any system. We wanted to be able to build it once and ship an application to different operating environments. So on screen, you'll see a picture of a boat or a ship. And on top of that are containers. In this example, the container, the operating system is our boat. And the containers work within that to give isolation to our application. The containers are application containers. And what happens is inside of there, we have an application. All of its dependencies in its environment are bundled up. They don't touch any other running application on our system. So we could say, we could bind port 80 on both of these without any kind of conflict. It's very convenient. Or we could have 2 applications that use the same library, but different versions without any conflict. So we're abstracting, or we're isolating our application away from the operating environment and away from any other running application on our system. Containers are also very lightweight because they're a construct within our operating system. So this means that starting a new application with a container is as simple as loading or unloading a container onto a boat. If we were using virtual machines, to get the same kind of isolation, we would have to rebuild the boat. And that's effective, but maybe not efficient. So as a best practice, we're going to use containers to package and distribute our applications. And I'm actually going to demo this now. So I'll be demoing Docker, which is a container image format. It's very popular. The same principles would work if we were using Rocket, another image format. The command lines would be different. And so the very first thing I want to do is build my application. I'm using Go version 1.6. There's no magic here. I'm going to build the monolithic version first, And then later we use the microservices one. It's just easier to show everything when it's bundled up as one. Normally, if you build Go, it's not this complicated to write out. But I want to build a static binary. And so that is a little more involved. Oops. OK. Now, once this is built, we're going to have a binary that we can test out. And I'll be able to show you the functionality of this application. Both the monolith and the microservices do the same thing. We've just broken the microservice up into smaller components. So now that I have a binary, I can run it. I'm going to find some ports. I'm actually going to run that in the background. And now I can do things like curl to the endpoint. And I'll get back a greeting. Thank you. You guys are paying attention. I like it. So I got back a greeting. If I were to hit up the secure route, I'm going to be denied access. So what we have to do is log in. I'm going to use the super secret password. And I have a token now. So I'm going to pass that token as a header. And this will give us access to this secure endpoint. Now, that's the only time I'm going through all of these steps the rest of the demo. For everything else, I'm just going to hit the regular endpoint. It's a lot of steps. But so now we have a binary. It works. We've tested it out. We want to be able to run this binary on any machine, on any system. And that's where Docker comes in. So I have a Docker file. And what this is it's steps to recreate an image. We're going to take all of the dependencies to run an application, and we're going to bundle this up into one image. So the very first line is saying, what is our base image, or what is our base operating system? Now, as a best practice, we want to use something that's very, very small. We don't want to bundle unnecessary things into our application. So Alpine 3.1 is 5 megabytes in size, but it still gives us functionality where we could SSH into a container and ping and make sure that our internet is working. Basic debugging we'd need in production. Further down, you'll see that I'm taking the binary I just built, and I'm going to store it in the container at user bin monolith. And then when I start up the container, I'm going to run the monolith. So I can start this container and run it pretty much like an application. So I'm actually going to do that now. I'm going to build the image. I'm going to give it a name, monolith, and I'm going to give it the version 1.0.0. And what we see here is we're taking the content of that directory, and we're setting it up to a build daemon, and it's going to recreate an image from this. And the image should be 13 megs, because we have 8 megabytes for our application, and then 5 for Alpine. Now, one reason this was so small is because we didn't use Docker to build our application. We used Docker as an environment to package and distribute. We build our application outside. And that lets us do things like use a continuous integration system or manually build an application like I just did. So we can keep our Docker images really small. So now I'm going to push my image. Push onto the cloud. Or into the cloud. This is going to go up to Docker Hub because I didn't specify a different registry. We could use different ones like Quay.io or GCR.io, and that's just prefixing it. Docker Hub's the default one, so that's what I used. Now, what this lets me do is, if I get rid of the image on my local machine, Oops. So now I don't have that image on my local machine. It doesn't exist. If I were to run and say, Docker, I want to use that image, let me fix a typo right quick. It couldn't find the image locally, so it went and pulled this down. So now I can do things like find the image ID. I can inspect it to get an IP address. And now I can hit this endpoint, just like the application I had locally on my machine. So that's pretty cool. We now have an image that we can ship to almost any operating environment it's going to run. If Docker's installed, this is going to work. So at this point, I thought I knew everything I needed to know to write scalable applications for the cloud. I knew how to break it down into smaller pieces that were easier to maintain or easier to ship and distribute. I knew how to package those into a container, and I knew how to ship those. But it turns out that packaging and distributing applications is a small part of it. We have to worry about, is your container running in the wild? Is it online? Once it's up there, how do you discover it? How do you access it? How do you connect the network to it? Security. How do you manage passwords and sensitive information? There's a lot of complexity that comes with managing containers. And so, as a best practice, we want to automate and monitor everything we can, because we don't want to get woken up in the middle of the night, responding to a pager, to jump on a terminal or a command line, just to restart a container. We want to use a framework or something that can handle this complexity for us and monitor it and automate as much as we possibly can. Now, ideally, this framework isn't going to lock us into any one way of doing things. We don't want to be locked into a container format, a cloud provider, or again, any specific set of tools. We want a framework that's going to be flexible and let us tell our own story. Because as our application evolves, the tooling that we're going to use is going to evolve. And this leads me to Kubernetes. Kubernetes is an open source container automation framework. It's written in Go, and it's hosted entirely on GitHub, so you can go and check it out yourself, even commit to it. It's an open API, so CoreOS uses it with AWS, GCP, we use it. You see me using Google Container Engine Next, which is a hosted version. Amazon or Azure, Microsoft uses it too. So you're not locked into any one cloud provider. It's pluggable, so you can write like your own scheduler or your own tooling with it. And it's based on years of Google's experience with running containers internally. So it's something that lets you scale up from a small app like I'm demoing today to production needs. You see that there's a lot of enthusiasm with Kubernetes as well, too. On screen, you see a snapshot of the commits to GitHub. And for the version 1.2 release, there was over 5,000 commits. So Kubernetes is really fastly growing. Now, during this demo, I don't have time to show you all of the features in Kubernetes. Version 1.2 was designed to make it easy to scale and easy to deploy. 1.3 is adding a lot of very cool features. Maybe after Come Find Me, we can talk about more of them. Today, I'm going to show you like the basics to get started and clear the remaining hurdles. And so you can see that there's over 1,000 external projects that are based on Kubernetes. It's one of the top projects on GitHub, and there's companies that are using it with 100 nodes or 100 machines up to 1,000. So today I'm showing a very small application, but Kubernetes is a framework that will let you grow from little to much bigger. And the best way to see the power of Kubernetes is to demo it. So what I'm going to show off here is using Kubernetes to run that same image. So before we use Docker to run a monolith, now we're going to use Kubernetes. So I could say kubectl, which is the Kubernetes command line tool. can say run Now, what happens here is Kubernetes created what's called a deployment. I'm going to explain each and every one of these concepts after this. But what this does is, behind the scenes, it creates some pods. And pods, you can think of them as our applications. So I have an instance of our application running in the background. If we look further, I'm going to actually describe it, and we can see all the steps that got run in the background. I work at Google, but spelling is very difficult for me. Okay. So I actually want to describe this pod, because we can see the Docker commands that got run in the background for us by Kubernetes. So I'm going to make this smaller for a second. Can you guys still see that? All right. So we'll see that after our container was scheduled, we pulled the image. Just like I pulled it manually before, Kubernetes pulled that for us. And then it actually created a container with that image and started it. So Kubernetes handled all of the Docker for us. Now, I want to be able to access this pod. And pods get internal IP. So I could use port forwarding, or I could use some kind of init scripts, but there's other ways to do it. kubectl gives you an expose command. I'm going to open up port 80, and I'm going to make the type load balancer. This takes a second to start up, but what this did is it created what's called a service, a persistent endpoint for us to access our pods with. If I look at this service, right now it doesn't have an external IP address. It's creating one. So let's actually check that out. You can see that we automatically picked up an endpoint. It saw our pod. If I were to scale up my application, or make 3, we can see that we picked up these endpoints. Our service picked those up automatically. So it's feeding traffic to our application without us having to manually configure that. If I were to look behind the scenes a little bit further, I can see that I have 3 versions of our application running too. So let's send traffic to them. I now have an external IP address that I can hit. And I get our familiar message back. So what was happening behind the scenes there? Everything starts with an application. And in Kubernetes, the application is the pod. You can think of it as one or more containers housed together that know how to play well with each other. They're going to be scheduled together. They can communicate with each other. They share a namespace. So if we have data files that we want to access, every container in this pod can access it. We also have one IP address per pod, which is pretty nice because I can have 2 versions of my application running, and they can, again, both bind port 80 with no conflict. Now, every object in Kubernetes gets this arbitrary key value data, and this is how we do grouping. This is how our service was able to pick up the pods behind the scenes. So on screen, you see that I have 2 applications, and they both have labels. They have a version, and they have a track. If I were to select the V1 version, I would select every application. So before, my service was selecting everything that was app equals monolith. If I were just select track equals stable, I'd only get one of those. Now, We talked about services a little bit before. Services are persistent endpoints for IP addresses. They can be internal or external. So if we have backends that we want to be able to communicate with each other, we would use a service for that. But if we wanted to access these outside of our cluster, we'd also use a service for that. These are dynamically created, so services can dynamically pick up pods to send traffic to. And they can have different types. We saw the load balancer one, and that's just going to round robin traffic to pods that are targeted by our service. Now, to this point, I haven't really talked about machines. Does anyone notice that? So the reason why is Kubernetes abstracts away the machine so we can focus on our application. Deployments are an object that are manage our pods or our applications for us, and it are managed scheduling them. So on screen, you'll see that I have two machines called nodes, and I have one version of my application, one replica that I want running. Deployments are used to drive our desired state, or our current state closer to our desired state. So if I want one, I've got one, I'm good. But if I change that and I say I want two, the deployment or managed scheduling a second node. If a machine were to go down, Kubernetes would handle rescheduling the second one until our current state matched our desired state. And that's pretty powerful. So now I'm going to take our application that we've been using, the monolith, and I'm going to use Kubernetes to show you how to set up deployments for our microservices version of the app. So we're going to have our external-facing front end that can be accessed outside of our cluster, and we'll have two persistent back-end services, our auth and hello, all communicating with each other. So the first thing I want to do is show the configurations for our front-end service. We're going to be listening on port 443, and this is going to be a secure endpoint. So we're going to have to pass sensitive data. I'm not going to get into this too much. I'm just going to manually create it here. But Kubernetes gives you a way to pass sensitive data without baking it into your container or storing it publicly on GitHub. And then I'm also going to say if I hit my default route, I'm going to forward that traffic to the hello endpoint. This is a named endpoint, and Kubernetes is going to set this up for us. So I don't need to know the IP address as long as I set up my services. If I hit the login endpoint, then I'm going to pass that to the authentication handler. So really quick, I'm going to create that configuration data that I need. And I'm just going to make that from the file we just saw. I'm also going to create a file for our sensitive data as well. And all of these commands are they're on GitHub publicly, so you can follow along. And they're also in the space, I think it's called, that they set up for I/O. So if you want to see everything I'm running, check that out. OK, now that we have that data, let's look at some of our other systems. So for our auth service, we're going to create a service named auth. We're going to forward traffic from port 80 to port 80. This is an internal service. We're not saying it's a load balancer or anything. So we can only access this internally. But if you notice, this is where we got the name for our endpoint. If we look at the deployment, we're using the Ask Carter auth image. And we're just taking traffic on port 80 and 80. So I'm actually going to go ahead and create that. And I'm going to do something very similar for the hello service. Oops. So if we were to look at our service now for the front end, which is a little more complicated. We can see that we're going to take traffic on port 443, which our Nginx is looking for, the internal container, and we're going to load balance to any pods that are picked up by this service. And if we were to look at our deployment as well, you can see that we're just using, we're using Nginx for that. And so this data that we mounted before, that we created before, this is going to be mounted by our container. Kubernetes is going to take care of loading all of our sensitive data and our configuration before we even start our pods. So I'm actually going to create that now. So let's look at the state of the world. Oops. If we look at everything we have going on, we have our monolith that we created before with 3 replicas. We have a hello service with 7 replicas. We have a front end and we have an auth system, 1 each. If we were to look at the services we have created, we have our monolith, and our front end is still loading up its external IP. And once it does, we'll be able to send traffic to it, and it's going to know how to communicate with its backends that were set up. Kubernetes handled that for us, so we didn't have to manually hook all that up. That's pretty cool. So I'm actually going to wait for that to come online. And while I'm waiting, I'm just going to change the number of pods we have running. So I'm going to say my hello service, I think that 7 is too many. So I'm going to change that to be 6. Does anyone here use Vim? I need some of you guys to teach me this after. None of that. All right. Sorry. So I'm going to apply that change to my deployment file. Ooh, thank you. And now if I look at the number of pods, it's hard to tell. Now if I look at the deployments, I can see that I have 6 of that application. So scaling is really easy with these deployment files. So let's actually send some traffic that way. I have a front end. This one is secure. And I got that very familiar message back. So I'll be honest. At this point, I thought I knew everything I needed to know. I knew how to break an application down into smaller bits. I knew how to package that into application containers that could be shipped and distributed. And I knew how to use an automation tool to automate and monitor everything. What more was there for me to learn? Well, someone asked me, what about code updates? What if the intern Bob is coding blindfolded again and he ships bad code out? It happens. Well, in that case, we want a deployment story that's going to let us roll out updates cautiously, but roll back instantly if we need to, if something goes wrong. Some best practices in this field have turned out to be blue-green deployments or canary deployments. And you can do that with Kubernetes, but what I want to show you is our rolling update. But as a best practice, we want to make sure that we have a way to deploy cautiously. So on our deployments, if we push out an update, there's an option, and we could say we want a rolling update. And what that'll let us do is gradually scale up a new version of our application, send traffic to it at the same time as our old application is getting traffic, and then gradually roll down the other one as we're scaling up the new version. And what this lets us do is if something goes wrong, we can minimize downtime because we still have our old version of the application in production. So if I ran the command, I could spin up my new application, goodbye. I'd start getting traffic, so now both are getting traffic at the same time, and I'll gradually start spinning down the old one until I have whatever the desired state of the new one was, in this case, 3. So let's check that out. So this time what we're going to do is we're going to change some code. And since we're nearing the end of the talk, instead of saying hello, let's say goodbye, which makes me kind of sad, guys. We're going to rebuild our application. And once that's built, we're going to package this into a Docker container and ship it back out. From there, we use Kubernetes to roll out this new change, and we can see it live. So we're going to make 2.0. So far, we've been using Hello 1.0. I created those images earlier. Oops. While that's waiting, I'm going to start a little script. All this script does is it just constantly pings the endpoint. There's no magic here. I'm grabbing the front end's external IP address, and then I'm just going to constantly curl it. So right now I'm getting hello messages. Once I push this change, so we're going to push this change up to the cloud. And then what I'm going to do is I'm going to actually modify our deployment file. This time I'm going to tell the hello service to use a different version of This time I'm going to tell the hello pod container to use version 2.0. Once I apply that change, we're going to start seeing the new one getting traffic. So this takes a little bit. This is a gradual process. It's not instantaneous. What we'll start seeing is goodbye messages getting sent out. So we're getting a few right now. Over the next few seconds, we're going to see more and more until eventually all we're getting back is goodbye. So we just did a live update of our code. It's a very small sample application, but there was no downtime. Now, if something happened and maybe I didn't want to tell you guys goodbye, I could undo that rollout. And we'll see the traffic start to revert back. So Kubernetes makes it very easy to push out updates and changes to code and have that taken care of for you. And now we're starting to see some of our hellos. And eventually this is going to go back to the state that we had before, where it's all the hello version of our application. And that's pretty cool. So to start wrap up some of the best practices we talked about, there's 3 major hurdles to getting an application online. There's the application. We want to make sure to package that in something that can be shipped everywhere. So we're going to use containers as a best practice. For the infrastructure needed to manage that complexity, we want to automate and monitor whatever we can. And and we want to make sure that we're not locked into any set of tooling. Finally, we want to make sure that once we're in production, we deploy cautiously, with care, and that we can roll back when we need to. So Kubernetes gives you all of this. Now, I learned these things from an expert over 4 months of making a course. But taking advice from a guy on a bus is normally not good for your career. So check out the Scalable Microservices with Kubernetes course. Kelsey Hightower, myself, Adrian Cockcroft, we're all in it. It's part of Udacity's DevOps Nano Degree program, which is just starting up. I've taken some of the classes, it's pretty cool. And in fact, it's probably easier to just have the trailer tell you instead of me. So I'm going to play that now.
Containers, microservices, Kubernetes. These are a few of the hottest buzzwords in scalable computing today. But what's driving the hype? In the last decade, user demand for always-on applications have grown exponentially. Users expect their favorite sites and favorite services to be up 24/7, no exceptions. Many developers have focused on application patterns such as microservices to meet this need. But what about the infrastructure needed to support these always-on apps? This course from Google and Udacity is going to show you step by step from theory to production how to meet and exceed these demands using tools that are available today. Learn from industry experts like Google's Kelsey Hightower and the former cloud architect of Netflix, Adrian Cockcroft, about modern application design, best practices for using Docker to package and distribute containers, and how to manage deployments and scale applications with Kubernetes. So what are you waiting for? If you want practical, hands-on advice for containerizing your app and managing it at scale, sign up today.
So I'm really proud of that course. And I don't know if you guys saw the magical fist bump, but that's how you'll feel inside if you take this course after. So to wrap up, I just want to say, Kubernetes is a container automation framework system that's flexible, it's open, it's very powerful, and it lets you tell your own story. So this was my Kubernetes story. I definitely want to hear yours. I'm not going to have time for questions, so you can hit me up on Twitter always. I do want to hear your story, or you can find us at the sandbox outside. Thanks for checking that out, guys.